Ever wondered why your kitchen utensils do not rust? The answer lies in the composition of stainless steel. How often do we pause to consider the everyday marvels around us, like the stainless steel that forms the backbone of our kitchen spaces to the towering skyscrapers? What makes stainless steel immune to rust? It's a fascinating tale that combines chemistry, engineering, and a bit of magic. So buckle up, because we're about to embark on an incredible journey. Now brace yourself as we delve into the fascinating world of stainless steel making. Steel, a key component of stainless steel, has been around for millennia, but the stainless variety, not so much. Stepping back in time, steel making is as old as the Iron Age, when our ancestors discovered the transformative power of heat on iron. Fast forward to the mid-19th century, we had Sir Henry Bessemer developing a process for mass-producing steel. However, the true game changer, stainless steel, didn't make its entrance until the early 20th century. Its invention was driven by the need for a material resistant to corrosion, a common problem with plain steel. Enter Harry Brearley, a British metallurgist, who in 1913, while experimenting with steel alloys to prevent gun barrels from eroding, stumbled upon a formulation that resisted rust. This chromium-rich alloy was the first of its kind, the first stainless steel. So, the birth of stainless steel was a revolution for industries worldwide. To make stainless steel, you need more than just regular steel. At the heart of the process are a few key materials that give stainless steel its unique properties. First up is iron ore. This is the base ingredient that forms the majority of the stainless steel we know and love. It's abundant, strong, and capable of withstanding high temperatures. Next we have nickel. This silvery white metal is added to the mix to enhance the steel's resistance to corrosion. It also lends a smooth, polished finish that we often associate with stainless steel. Chromium then enters the scene. This hard, brittle metal is responsible for the steel's stainless quality, creating a protective layer that prevents rusting. We also have other elements like carbon, silicon, and manganese that play their parts, tweaking the steel's strength, flexibility, and resistance. With these ingredients in hand, we can now start the process of making stainless steel. The creation of stainless steel begins with a hot and fiery step. Imagine a gigantic electric furnace, a veritable titan of industry, glowing with the intensity of 1,000 suns. This is the heart of the stainless steel making process. This is the melting pot. Here, the raw materials we discussed in our previous scene, iron ore, chromium, nickel, manganese, and others, are subjected to an intense heat that would make the surface of the sun seem like a winter's day. The temperature inside this electric furnace reaches a blistering 2,700 degrees Fahrenheit. That's right, 2,700. It's a heat so intense that it melts these raw materials down into a molten soup. But it's not merely a matter of turning up the heat and letting things melt. Oh no, the process is more nuanced than that. The temperature must be carefully regulated, the timing meticulously measured. Too hot, and the metals could burn, altering their chemical composition and ruining the batch. Too cold, and the materials won't fully melt, leading to an uneven mixture. And then there's the timing. Each material has its own melting point, and so they must be added to the furnace in a specific order at specific times. It's a dance of precision and patience, choreographed to the ticking of the clock and the rising of the temperature gauge. As the raw materials melt, they blend together, forming a homogeneous liquid metal mixture. This molten mixture is stirred continuously to ensure that the elements are evenly distributed, creating a consistent alloy. What was once a collection of individual materials is now a singular entity, a molten concoction brimming with potential. And just like that, the raw materials transform into a molten mixture ready for the next step. This is the end of our journey through the melting pot. But don't worry, the adventure is far from over. There's still a lot more to learn about the fascinating process of making stainless steel. Now the molten mixture undergoes a refining process to become steel. The journey of this fiery concoction is far from over. This is where the real magic happens, where the raw mixture is transformed into stainless steel. The refining process in steel making is a critical step. It is here that the molten steel is purified and adjusted to achieve the desired chemical composition. But how does this happen? Well, it all comes down to a sophisticated process involving a number of stages. Firstly, the molten mixture is treated to remove impurities. This is done by a process known as slagging. Slagging involves introducing materials that react with the unwanted elements, forming a separate layer of slag on top of the molten steel. This slag, rich in impurities, is then skimmed off, leaving behind a cleaner, purer mixture. But the refining process is not just about removing unwanted elements, it's also about adding the right ones. To create stainless steel, the molten mixture needs to be enriched with certain elements. This is where alloying comes into play. Alloying is the process of adding specific metals to the molten steel in precise quantities. The main alloying elements in stainless steel are chromium and nickel. Chromium gives stainless steel its signature resistance to corrosion, while nickel enhances its toughness. But these are not the only elements that can be added. Depending on the desired properties of the final product, elements like molybdenum, manganese or nitrogen can also be introduced. The refining process is a careful balancing act. It involves exacting precision and meticulous control to ensure the right amounts of each element are present. The result? A molten mixture that has the perfect blend of characteristics to make it stainless steel. But the story doesn't end here. The molten steel, now refined and ready, is still a long way from becoming the shiny, durable material we're familiar with. After refining, the molten steel is now ready to take shape. Shaping the steel is where the true magic happens. When we say shaping, we're talking about the transformation of molten steel into various forms. This process is as much an art as it is a science, requiring a keen understanding of both the material and the end goal. Whether it's slabs, blooms or billets, each form has a specific purpose and a unique process to achieve it. Now imagine a massive piece of dough in a bakery, ready to be rolled and shaped into a variety of baked goods. That's what molten steel is like at this stage. It's pliable, malleable and ready to be formed. This is achieved by passing the steel through high-pressure rollers that squeeze and shape it to the desired thickness and shape. But just like dough, steel too needs to be baked, or rather cooled, to maintain its form. This is where the cooling process comes in. It's not just about bringing down the temperature, it's about doing so in a controlled manner that ensures the steel hardens properly. The cooling process is like the final act in a dramatic play. It's the conclusion, the moment of truth, where the steel's strength and durability are tested. Rapid cooling or quenching can create a harder steel, while slower cooling results in a softer, more malleable product. The speed and method of cooling can significantly impact the steel's characteristics, from its tensile strength to its resistance to wear and tear. In essence, the shaping and cooling processes are the final steps in the creation of stainless steel. They give the material its form and hardness, making it ready for a multitude of applications. From the utensils in your kitchen to the skyscrapers gracing city skylines, stainless steel in its many forms is all around us, thanks to these critical processes. And voila, we now have stainless steel ready for use. Before we wrap up, here are some fun facts about stainless steel. Did you know that stainless steel is 100% recyclable? In fact, an astounding 60% of all stainless steel produced today comes from recycled material. It's a testament to the longevity and durability of this remarkable material. Furthermore, stainless steel is not just a workhorse in our kitchen appliances or surgical instruments, it's also a star of the architectural world. Take, for instance, the iconic Chrysler Building in New York City. This Art Deco masterpiece, soaring high into the Manhattan skyline, is clad in a shimmering skin of stainless steel, making it a dazzling testament to the aesthetic versatility of this material. Stainless steel also has a secret superpower. It is self-healing. Yes, you heard it right. Due to the presence of chromium, a thin protective layer forms on the surface of the steel, which helps in preventing corrosion. If this layer is damaged, it can actually rebuild itself when exposed to oxygen. Now, isn't that truly amazing? So from raw materials to the shiny, rust-resistant product we see every day, that's the journey of stainless steel. A journey that showcases the perfect blend of science, art and environmental consciousness, making stainless steel a truly remarkable material of our time.